So here's the first lesson for Chapter 6. This lesson is for Section 6.1, Equation of a Line in Slope Y-Intercept form. So this chapter is all about equations of lines. We're going to start off by looking at the equation of line in slope y-intercept form. So in the form y equals mx plus b. Why do we call this slope y-intercept form? Because in order to write the equation of a line in slope y-intercept form, you need your m value, the slope of the line, and you need your b value, the y-intercept of the line. And hopefully you remember from last chapter we learned what the slope and the y-intercept of a line are. So the first question we want to do here, we want to complete the following chart. So we want to look at the equation of the line and be able to pull out from that equation of the line what the slope of the line is and what the y-intercept of the line is. So remember, the equation of a line is y equals mx plus b. Remember, m is what you have to multiply the x value by, and b is the initial value, or what you want to add to that product of mx. Okay, so in our first equation here, in order to determine the m value, you need to look at what is x being multiplied by. X is being multiplied by -2, so that is our slope. Our slope is -2. The -2 is in the place of the m in the formula y equals mx plus b. What is in the place of b in our equation here? You see a -5. So what's being added to our product of -2x? It's -5. So our y-intercept, our b value, is equal to -5. With our next equation, y equals x plus 2, what's being multiplied by x? If you don't see a number in front of the x where the m goes, know that there's an invisible 1 there. So this x is being multiplied by 1. So our slope of the line is 1. Why don't they bother writing that 1? Well, what's 1 times x? 1 times x is just x. So essentially there's no point in writing the 1 in front. So if you don't see a number in front of the x, know that there's a 1 there. What value is in place of the b value? You see a 2 that's being added to the product of 1 times x. So our b value, our initial value, or our y-intercept, is 2. The next equation, what's being multiplied by x? It's the 2 over 5. So that is our slope, our m value. It's 2 over 5. And what's being added to that product? 8 is. 8 is in place of b in the formula y equals mx plus b. So our y-intercept, our initial value, is 8. And the next equation, y equals -1 over 2x. What's being multiplied by x? We see a -1 over 2 being multiplied by x, so that's my m value, -1 over 2. What's being added to that product? Nothing is being added to that product, so think of this as a plus 0 if you want. Therefore, our y-intercept, our initial value, is 0. For the last one here, y equals 4, we don't even see an x value, okay? The only way there could be no x value is if the x was being multiplied by 0. So think of this as a 0x plus 4. What's 0 times x? 0 times x is just 0. That's why all we're left with in the equation is just y equals 4. Okay, so our slope in this case is actually 0, and our y-intercept is actually 4. You see 4 in place of the b value. Okay, and this is actually the equation, y equals 4 right here. This is actually the equation of a horizontal line. So remember, horizontal lines have a slope of 0. But we'll talk more about horizontal and vertical lines in a minute later on in this lesson. Okay, example 2. So example 1, given the equation, we were able to determine the slope and the y-intercept. Now for example 2, I want to be able to identify the slope and the y-intercept given the graph of the line. So in order to find the slope of a line, there's 2 ways you can do that when you're given the graph. You can look at the graph, choose 2 points, and then calculate the rise divided by the run, and that'll give you the slope of the line. Or you can choose 2 points on the line and use the algebraic formula, calculating the difference in the y divided by the difference in the x. Difference in the y's, you're going to do your second y coordinate minus your first y coordinate, divide that by the difference in your x values, your second x coordinate minus your first x coordinate. Remember, you can use either of these formulas because the rise of a line is the vertical distance between 2 points, which is actually your change in y, which is what leads to the formula y2 minus y1. That'll give you the change in the y coordinates. The run of a line is the horizontal distance between 2 points, which is what gives us our change in our x values, which is what leads to this formula x2 minus x1. Okay? So either formula will work. I'll use both of them to show you how both of them can be used in this situation. So before you start using either of these, you need to find 2 lattice points on your line. So don't choose a point like this. Okay, this point right here, we can't tell exactly what the coordinates of that point are. The coordinates might be 2.3 and then negative 3.2. It looks something like maybe that, but we don't know exactly the coordinates of that point. So we're not going to choose that point. We want to choose a lattice point. And a lattice point is a point that intersects the grid exactly. So this point right here, for example, we can tell exactly what that point is. That point is at 3, negative 3. So we know the coordinates of that point are 3. Oops. Here we go. Are 3, negative 3. And then I need another lattice point. This point right here. I can clearly tell the points, the coordinates of that point. That point is at 6, negative 1. Okay, so now if I want to find the slope of my line using rise divided by run, all I have to do is figure out, to get from my first point to my second point, I need to go up 2 units. I need to go up 2 units, so that means my rise is positive 2, and I need to go right 2, 3 units. That means my run is positive 3. Okay? So, plug that into your rise over your run. So if my rise, if I'm going up 2 units, I know it gives me a positive rise, so positive 2. My run, I know I need to go right 3. That gives me a positive run of 3, so my slope is 2 over 3. What if I want to use the formula y2 minus y1 over x2 minus x1 to calculate my slope? Oops, I didn't mean to erase that. Let me put this back. That was 0.3, negative 3. I'll just delete that and write it again. 0.3, negative 3. I just want to erase these lines where I showed the rise and the run. Okay, because now I'm going to use the other formula, y2 minus y1 over x2 minus x1. Okay, so what I need to do to use this formula, I need to figure out my change in y values divided by my change in x values. So I need to label my points as my first point and my second point in order to use this formula. So my first point, doesn't matter which one is your first, which one is your second, just choose one of them. So I'll choose 3, negative 3 as my first point. I know a point has an x and a y coordinate, and since this is my first point, I'm going to label this my x1 and my y1. My second coordinate is going to be 6, negative 1. So this point right here, since that's my second point, I'm going to label this point x2, y2. Plug in the information into my formula. So y2 minus y1 is negative 1 minus negative 3 divided by x2 minus x1, my change in x coordinates. It goes from, I'm going to have 6 minus 3. And then simplify this. Negative 1 minus negative 3 means negative 1 plus 3, which is 2. 6 minus, what was that number here? That is supposed to say, that's my x1 value, which is 3. So that's supposed to say 3. 6 minus 3 is 3. So I get a slope of 2 over 3, which is exactly the same as the slope I got when I used rise over run. Okay, so either way you feel more comfortable finding the slope from the line on a graph, either way is fine. You get the same answer either way. You can find the y-intercept by looking at the graph and checking where the line crosses the y-axis. Remember, the y-intercept means where does this line cross the y-axis, and it clearly crosses the y-axis right there. All you have to remember the y-axis is the vertical axis, okay? So look at your vertical axis and figure out where does the line cross the vertical axis. It crosses it right there at negative 5 on the y-axis. So that means our y-intercept, our initial value, our b value, is equal to negative 5. Okay, so now I have the slope, I have the y-intercept. That's all you need to write the equation of the line in slope y-intercept form. You need your slope, which I determined was 2 over 3. I need my y-intercept, which I determined was negative 5. Plug that into the equation y equals mx plus b, and I get y equals 2/3 x minus 5. Remember, whenever you write the final equation of a line, you plug in for m and b, and you don't plug in for x and y, because x and y stand for all of the coordinates that make up that line. Okay, part B, I want to write the equation of this line in slope y-intercept form, so I need the slope, I need the y-intercept. Remember, you can find your slope using one of two ways, using your rise over your run, or the algebraic method of finding the difference in your the difference in your y values divided by the difference in your x values. Okay, because remember, the difference in your y values will find you the vertical distance between your 2 points, which is the rise, and the difference in your x values will get you the horizontal distance between your 2 points, which is the run. So either way is fine. just to save time, I think using rise over run is probably faster, so I'm going to do that. Choose your two lattice points. So here's a point, here's a point. I can clearly tell what the coordinates of those points are. To calculate my slope, all I have to do is figure out what my rise and my run are. To get from my first point to my second point, I have to go down 1, 2. Okay, going down, I remember, is going to give me a negative rise. So I'll have a -2 for my rise, and then my run, I have to go to the right 1 unit. Going to the right gives me a positive run, so it gives me a run of 1. So my slope equals rise over run, which equals -2 over 1, which is equal to -2. So the slope of my line is -2. To find the y-intercept of my line, all I have to do, I have to look at the vertical axis of my line and figure out where does my line cross that vertical axis. Just want to erase this stuff. Okay, so to find the y-intercept, look at the vertical axis, the y-axis. Figure out where does my line cross the y-axis. It crosses the y-axis right here at 3 on the y-axis. So that is my b value. The y-intercept crosses the y-axis at 3, so my b value is 3. So my slope was -2. My y-intercept, my b value was 3. Plug that into y equals mx plus b, and we have the equation y equals -2x plus 3. So remember to write the equation in slope y-intercept form, just plug in for m and b, don't plug in for x and y in your final equation. Okay, now we're going to do a horizontal line and a vertical line and come up with a general equation for all horizontal and vertical lines. So if you have a horizontal line, let's calculate the slope. Let's use this formula this time, the algebraic formula, by finding 2 points, find the difference in the y's, dividing that by the difference in the x's. So let's pick 2 points. I'll choose this point right here and this point right here. The coordinates of those points, well, I'll say my first point, point 1, was at -1, 4. And my second point, point 2, was at 2, 4. Okay, so my first point I'll call x1, y1. My second point, x2, y2. Because remember, every point has an x and y coordinate. My first point is my first x coordinate, my first y coordinate, and second point is my second x coordinate, my second y coordinate. If I want to calculate the slope, plug that into y2 minus y1 over x2 minus x1. I get 4 minus 4 divided by 2 minus -1. That gives me 0 over 3, which equals 0. Okay? And in fact, all horizontal lines will have a slope of 0. Why? Because, remember, y2 minus y1 is the difference in your y coordinates. And that means that's the vertical distance between 2 points, so that's your rise. Of a horizontal rise, to get from one point to any other point on the line, you never have to go up or down at all. Okay? It has no rise. Therefore, your rise is always going to be equal to 0. Okay? So if the slope of a line is rise over run, you're always going to be doing 0 divided by something. 0 divided by anything is 0. Therefore, your slope is always going to be 0 for a horizontal line. What's the y-intercept of this line? Where does it cross the vertical axis? It crosses the y-axis at 4. So my y-intercept is 4. My y-intercept, my b value, is equal to 4. Okay, so if I want to write the equation of this line, my slope, my m value is equal to 0. My y-intercept, my b value, is equal to 4. The equation of the line is y equals mx plus b. Plug in for m and b, so y equals 0x plus 4. What's 0 times x? 0 times x is 0, so the x is gone. So I should write this equation as y equals 0 times x is 0, so all I'm left with is the 4. Y equals 4 is the equation of this horizontal line. So in general, all horizontal lines have a slope of 0, all of them, because the rise of a horizontal line is always 0. And the equation of the line is in the form y equals b, where b, I should add here, b is the y-intercept. B is the y-intercept. Okay? So the equation of all horizontal lines is in the form y equals b, where b is the y-intercept. So to write the equation of any horizontal line, you know it's going to be y equals whatever the y-intercept is. And the y-intercept of this line is at 4. Okay. Another way to think about this, look at this line here. What is the y-coordinate of every single point on this line? This point is at 2, 4. This point is at 1, 4. This point here is at -2, 4. Every point on this line is going to have a y-coordinate of 4. Hence, the equation of the line is y equals 4. Okay, so that's another way to think about it. Let's do a vertical line now. So vertical lines. If we want to calculate the slope of a vertical line, let's do it the same way by finding our difference in y's divided by our difference of x's. Difference of y's divided by our change in x's. So let's pick our 2 points. I need a first point to be my x1, y1. I need a second point to be my x2, y2. So my first point, let's choose this one right here. This point is at 2, 2. And let's use the point right below it. Sure, why not? This point is at 2, 1. So here is my x1, y1. Here's my x2, y2. Plug that into our formula, y2 minus y1 over x2 minus x1. I get 1 minus 2 all over 2 minus 2. 1 minus 2 is -1. 2 minus 2 is 0. And if you try and do this division on your calculator, -1 divided by 0, you'll get an error because you can't divide anything by 0. So what we say, this slope is actually undefined. And actually, the slope of all vertical lines is undefined. Why? Remember, slope is rise over run. Okay? Because the change in x coordinates means the horizontal distance between 2 points, which is our run. Okay? So if we choose any 2 points on a vertical line, is there a horizontal distance between 2 points? No, you don't have to go left or right. You don't have to go right or left to get from one point to another on a vertical line. Therefore, the run is always going to be equal to 0. Okay? The run is always going to be equal to 0. And you can't divide by 0. Therefore, we say the slope of the line is undefined. And the slope of any vertical line is going to be undefined. What's the y-intercept of this line? Well, does this line ever cross the vertical axis? No, it's actually parallel to the y-axis, so it's never going to cross the y-axis. It doesn't have one. There is none. There is no y-intercept. But what we want to look at, there actually is, it crosses the x-axis, and that's actually going to be important for this line. The x-intercept, we'll call this, is only important for vertical lines when we're writing the equation of lines in slope-y-intercept form. It crosses the x-axis at 2, okay? And that's going to be important when I write the equation. So the slope of this line, I said, was undefined. The y-intercept, it had none. So I don't have anything to plug into the equation y equals mx plus b. So we can't actually write the equation of a vertical line in the form y equals mx plus b. What I want to actually do, I'm going to write the equation of this line as x equals 2. Why am I writing it in the form x equals 2? Well, let's look at this line. What are the coordinates of all of these points on this line? The coordinates of this point, 2, 2. This point, 2, 1. This point is at 2, 0. This point is at 2, -3. Look, the x-coordinate of every point on this line is always going to be 2 because it never goes left or right. Therefore, we say the equation of the line is x equals 2. So all vertical lines have an undefined slope and an equation of the form x equals a, where a is the x-intercept. And if we look at the line that we just wrote the equation of, x equals 2, the x-intercept is 2. It crosses the x-axis right here at 2. Okay, one more question we're going to do. We're going to do a little bit of an application question interpreting a linear relation. So here's a distance time graph for Tracy's walk. Let's identify the slope and the vertical intercept, or the y-intercept, of the linear relation and explain what they mean. So slope, when I'm given a graph, I think it's easiest to use rise over run, so let's do that. I know my slope is equal to rise over run. Rise is the vertical distance change in y, run is the horizontal distance change in x. All I have to do is pick 2 points, I'm going to pick this point right here, this point right here, and I'm going to calculate my rise and my run. To get from my first point to my second point, I have to go down 1 unit. If I go down 1, I know that gives me a negative rise, so -1 for my rise. And I have to go right 1, 2 units. Going to the right 2 gives me a positive run of 2. So my slope is equal to -1 over 2. My y-intercept, where does this line cross the y-axis? Let me just get rid of all this stuff. Where does the line cross the y-axis? Looking at my graph, it crosses right here at 5 on the y-axis. So my b value is equal to 5. Okay? Now let's interpret what do these values actually mean for this question. Okay? Remember, we're dealing with a distance-time graph. The slope actually represents Tracy's blank. So remember, slope, the rise is the change in your y values, okay, the vertical distance between 2 points, and your run is the change in the x values, the horizontal distance between 2 points. In this case, on the vertical axis, so our y-axis, we have distance. On the x-axis, we have time. So essentially what we're doing, when we're doing change in y, we're finding out change in distance. And when we're finding change in x, we're finding out the change in time. So what we're doing, when we calculate the slope, we're actually doing change in distance divided by change in time. And hopefully you remember the formula that meets that criteria is for the speed. So we're actually finding Tracy's speed when we're calculating the slope of this graph. The negative value means that her distance from the sensor is actually decreasing. She's moving back towards the sensor. Okay, so the negative slope means she's moving towards the sensor. And her speed toward the sensor, if the slope is -1 over 2, if we're going to write that as a speed, I want to change that to a decimal. It's actually -0.5. And what units are we working in? We're working in distance, which is meters, time, which is in seconds. So she's moving, her speed, actually I should write that as a positive speed. It's just moving, the negative just tells us she's moving towards the sensor. So her speed toward the sensor, that takes care of the negative, is 0.5 meters per second. The y-intercept of 5 means that Tracy started walking at a distance of 5 meters from the sensor. So she started 5 meters away from the sensor, and then she walked towards it at 0.5 meters per second. Okay? The fact that our slope is negative means that the line is going to be going down to the right, which means she's walking towards the sensor. The equation of the relation? Well, the equation of a line is y equals mx plus b. My m value was -1 over 2, and my b value was 5. Therefore, the equation is y equals -1 over 2x plus 5. Okay, so that's it for this lesson. Make sure to go to jensenmath.ca, get the worksheet and try it, and let me know if you have any questions.